Alright everyone, today we have an A2485 M1 16-inch MacBook Pro that does not turn on after liquid damage. This particular device went to drive savers first and was sent back to the customer. Now this particular device has a massive internal short, which we're going to look at under the microscope, but the good news is it's in the backlight circuit, so we should be able to carve this out and hopefully save the data. So let's go ahead and look at this under the microscope real quick. So I'm going to switch over to that here. So instantly, as soon as I opened the device, I noticed there was that really strong burned PCB odor from it. And if you've worked on electronics long enough, you know what I'm talking about when I say this. And looking over here, I see that there is some flux around the backlight driver. Again, like I said, this was worked on prior by another company. And looking at this, we have this here, okay? That is a big internal short, and PP-bus AON is shorted to ground. This looks like more of a current sensing circuit here, but just look at this. This is just like decimated here. But anyway, we need to go over some imaging here, and there was 2 capacitors that was removed as well. So let's go ahead and look at our imaging first. So this is microfocus X-ray of the area of interest. So a few things just to point out here. Let's go over to zoom. The very first thing that I noticed on this is, hang on. Yeah, it should have zoom here. And why did that lose my, I see why. Go back, okay. So, very first thing I notice is we have loss of a solder ball here. So this is our backlight driver. You can see it's partially obstructed by capacitors on the other side. But we have a row of solder balls here, then we have a missing solder ball here, and this is actually the PP-bus G3 hotline, so it makes sense that that's kind of missing. If, given the fact that it was worked on prior, they probably just reflowed it, and if it didn't work, that was it. So we have that's a finding there, but the real thing is we want to look at this VS stack, and what I want you guys to look at is this right here. Okay, this is what a normal VS stack looks like. See the density on X-ray, dark is less dense and brighter is more dense. So a coil's dense, our solder is dense, but okay, it's less dense here. Going over here, all right, we notice this one right here is very much darker and it's more fuzzy, all right? So this is well defined here. This here is not well defined. It's very fuzzy. We zoom in. We're going to zoom all the way in here, and we're going to pan over. So it's very fuzzy right there, right? It's very fuzzy. And another thing, we have this weird appearance here of like this patchy kind of stranding here. And what this actually is the copper layers that are fused in the PCB. So that's not very reassuring. But with that being said, we have to just work at this and see what we can do. So looking at the other side, there isn't much else over here. There's no traces or anything. So if you're gonna have an internal short, you don't want it to be in a super critical area. And this is backlight, so it's not that critical. We just want data on this. So if we can get the device to boot, then with no backlight, that's a win. So with that being said, I want to just do a baseline measurement of PP-bus AON. So what do we have as far as ohms go? 0.70, so like nothing. So that's what we have. We're going to work on it, and we're going to try and clear this out. So the very first thing I'm going to do is we're just going to lightly kind of, get all this carbonized layering out of here. And for this to show on X-ray being that hypodense, this is deep, okay? This is probably 7 to 8 layers deep at minimum. These I think are about a 15-layer board, but yeah, this is definitely deep, and you could see that. And the reason why we see less density is because the normal fiberglass is all like turned to carbon, as you can see. So what I'm gonna kind of do, I just want to work on the edges. I want to get most of this kind of out of here, but then I'm going to go around the edges so I can see layer by layer. And I know it's losing focus somewhat. It's losing focus for me too, but I need to use pressure on this, and unfortunately the board will dip, so I'm going to do my best to kind of control that. But let's see, there we go. Look at that. That is just estimated. I'm not worrying about any of the other traces or vias here because this is, yeah, this is extensive, as you can see. It's all the way through, extending this way. Wow. Let me get some acetone to flush it all out. I kind of want to avoid using the Dremel and drill, but might have to break it out. Just that. This helps me see the field a little bit better. Just go around on this side. This is literally like cutting out cancer out of the board. Look at all this. We're making progress on it though. I can't see. There we go. Nothing on the other side yet, but this is gonna break through to the other side. I'm gonna tell you that right now. Just all the way through it, really bad. Now, there we go. Okay. I want to kind of get through it on the other side too. Wanted to see where it was. It's right here under this. Okay. I'm going to take off this coil, this inductor. And we're going to work on it through the other side too. There we go. See that right there? Well, I guess that's just a layering where the little inductor was, but here's the actual. Here we go. Okay. Look at that. Wow. This is probably one of the biggest internal shorts I've seen on a board. Like this is so extensive. It just keeps going on and on and on. Look at that. Wow. Wow, all the way over here. Look at that. I'm absolutely amazed by this because here's the real thing. Why didn't the fuse do its job on this board? Like, this should not have happened. You know how hot this had to have gotten? We're talking probably thousands of degrees here, and the fuse just did not blow. And I have to go dig all of this out because we can't let any of this black carbon, we cannot leave in there. That's all areas of burned and fused PCBs. So we have to carve out everything here that is carbonized in black until it looks clean. and we have to keep going until that. So yeah, this is, and on some circuits we could isolate PP bus. On this one there's no real resistor to do that. It may help if we try and cut out PP bus, the PP bus source here, but there's still going to be lines with voltage going through here that are ultimately going to be shorted. So we have to do our best to clear out as much of this as we can. And it just keeps going. Look, another pocket right here. Just won't let up. And which on the x-ray we did see it was pretty extensive, but I didn't think it was going to be this bad. Like, wow. This. Look at this. It still is going. All right, we're going to have to get the Dremel. There's no way I'm going to clear this out all by hand. We're going to have to Dremel it, and then we will work on it by hand after that. Let's get this cleaned up a little bit. There's just no way that this is going to budge by hand. I mean, look at all this. It still extends way deep into the PCB. Wow. I've never seen an internal short this extensive, I don't think. I've seen some pretty deep ones, but I think this is just over the top because this extends all the way through here. You could see it. It extends in every direction around here. That's crazy. All right, we're going to move in with the Dremel. I'll start at 10,000 RPM and then go up. We're probably going to need to go more than that, but let's just go. Let's give it a shot. Yeah, I need more. 20. Still going. All right, look at that. That is crazy. So we got to clean this area up now because there's a lot of copper, and then we got to move in with the X-Acto knife again. But this is just, I'm astonished. Like I don't think I've ever seen an internal short this extensive. It's like a plateau or something. Yeah, and it's still there's still more, guys. Like this isn't it. It still extends more, and there's some traces here, as you can see, but like there's nothing we can do. Like you look at those traces there. Like there's nothing we could do for that. This device will never have backlight again. We just want to get the data. That's it. Let's look at this side. So yeah, there's still more. I got to do the Dremel on this side too. Let's try and reposition a little bit. Yeah, see, there's still charred layers over here, under there. So right in this area here. So we're gonna go at it again on this side. Not as bad. Alright, I think it's a good spot. I'm going to rinse this board off to get all this copper off, then we will go more with the X-Acto knife. Alright, so this is what it looks after it was just rinsed, just using distilled water in this area. We're going to have to ultrasonic it anyway, but yeah, it's still pretty nasty looking. So now it's just a matter of digging and trying to clear all the layers out that we can. Then we can measure resistance after we clear a lot of this. Look, it just keeps going. It keeps going and going and going. Yeah, we're going to need to Dremel more, unfortunately. So let me just clear this around here. Yeah. This definitely is the worst I've seen. It's just... The reason why we don't want to leave any is because if we don't clear it all out and we put power on it, it might turn on, and then it's going to be a whole lot worse if it fails again, because sometimes they'll have partial shorts, it'll get hot, and then it'll melt, and then, yeah, it's not a good thing to leave it. That's why I'm very aggressive on cleaning all of it out like that, just because, you know, we don't want to leave any left behind there. That and still... Alright, at this point, all of these MOSFETs have to go because I'm going to be pretty close to this area, and this area is probably going to be gone. So, we don't care about this connector at all. It's burned too. Oh no, it's not. I thought it was. There we go. Alright, so Yeah. More Dremel time. We're going to continue. It's looking better. We are getting closer to the M1, so I don't want to get any closer in the other direction, but I think where we have a good margin, I think we're pretty much gone. I'm pretty sure most of the internal short is gone. We're just gonna take all this. I gotta make sure the layers have a good separation on them so they're not. This area is still not pretty right here, but I think the short is gone. Yep, that's cleared there. Another little spot gone. Okay, we are making good progress here. So this video definitely isn't for those that are looking for just a short, quick, easy repair, because this is as hard as they get. Like, this is literally as hard as any repair will get. It's definitely not one for someone who wants to give up easily, but... And my bit just snapped. Let me go grab a different one. Alright, nice new blade. Despite being new, this one is not as good. Oh boy, we found more. Just the gift that keeps on giving. It just doesn't stop. Look at this. It just does not stop. Alright, we're going to have to use the dental bits. There's no way. We're going to have to use the dental bits and just carve out this whole area, because we're just going to keep finding it. So we'll be back. Let's go grab a dental bit. Alright, we have our a pretty small drill bit here. We could go even smaller than this. This is actually one of the larger ones. But we are going to give this a shot. So we're going to set this to around 25,000 RPM. clean this off. So obviously, you know, we are making progress though. Let's go rinse this off real quick. Alright, now that we can see, I'm going to do a little more touching up with the X-Acto knife. So there's this like chunk of stuff right here. I want to just cut all this out. Got some more to do. And look, it's still going, guys. Look at that. It is still going, but I'm not going to take any more than that. I can separate the layers at that point. So yeah, I'm not going to push it any more than that, but it is still going. So now I'm just going to come around here, work all this out. Let me just do a little pilot cut kind of. I'm going to take this connector off, everything. We don't have to worry about anything around this area, guys. Yeah, this device is never going to get backlight. Just a reminder, this is data recovery only, and this is our only option. So let's keep going. And that's a broken bit. Let's grab another one. These bits are very fragile, just so you guys know. I'm going to go up to a bigger size so we don't keep breaking it. I think it hit that cap right there. I think that's what broke it. But yeah, these bits, you go through these pretty quick. They were not intended to do what we do with them, but they work. Think this is good. It's pretty much cleaned out. And look at that massive hole. But it looks pretty good. I'm debating on whether I should remove all this, but I don't think I have to. But at the same time, I think it might fight us a little bit with some layer shorts, but we'll see. Let's clean this up really, really well, and let's see if our short is gone, and then now we have to just go around it once it's clean and we could see really well, and just touch up any spots that look like they're connecting, and then we could ultrasonic this and see if it works. Alright, now we are mostly cleaned up here. So what I want to look for, let me see if I can show it. So see how all those layers are separated? That's good. That's what we want. What we don't want is any layers that might be touching. And what that's going to look like, and I don't see it here. This all looks pretty good. Let's go around it. Yeah, that'll look like a little contact spot. So I don't like this whole thing right here. See how close that is? Yeah, like right here. I don't like this. It's this little nub, but it's not touching, so we're fine. Yeah, this all looks pretty darn good, actually. I just don't like when they're this large, but what can you do? We had to take it all out, and we got most of it. There's still some right here. Might have to go more on this side, but that's all I'm going to do right now. Yeah, no, it just keeps going. No, we got to do more right here. We don't have a choice. That's going to go on fire as soon as we test it, so I don't want to leave that there. So we got to do more. I know it seems crazy, but luckily that's towards the edge of the board. So there's less risk. If it was going towards the M1, I'd try and weigh my option of just giving it a shot, but here we go. Alright, we're going to take this whole centerpiece out. Let's feel better. Come on. Alright, let's go clean it off again and let's reassess, but this is looking much better, so let's see. So now this is just really, we just have to clean up, make sure there's no fused layers, and like right here, I don't like that. Get that out of there, that's good, good. Anything that looks like this area, nope, can't have that. We don't want like a PP bus line being bridged to PP5VS5 or something like that. This board does not have PP5VS5, so I don't know why I said that, but yeah, you guys get the point. We don't want anything, any potential for a bridge, and it looks alright right here. Alright, let's flip it over. And I want just a little cut on this so I could actually see the layers here. So I'm going to go just do something like this. It's like that. That's good there. Just don't like to not see the field. So like that. And that's probably fine there. Yep, good. There's still more internal short here. Holy crap. There's still more right there. Wow. I can almost put my finger through this. That's how crazy this is. Look at that. It still extends. It's still going. Wow. Look at that. It is still going. Deep too, right here. Well, not that deep, but and yeah, who knows, maybe this happened because somebody bridged this, and just so everyone sees and knows I'm not like making stuff up, okay? And I've seen this is kind of personal for me because a lot of times when I do work for other stores and I tell them it's a no fix on data recovery, they're like, well, we'll send it to Drive Savers and see what they say. Okay, I'm not making this up. I'm not making this up. Drive Savers data recovery. All right, not making it up. It's been to Drive Savers before. Anyway, carrying on. So we gotta get rid of this bridge. We don't want a solder bridge here. So I'm just gonna remove all this backlight stuff. It doesn't matter at this point. It's not like backlight's gonna work ever again. They looks like they just reflowed it. They didn't do anything else. Craziness. Anyway. Wow, it's still going. It's Dremel time more. This is going on the side of the M1, so you know what? No. Scratch that thought. We're just going to try and get it by hand. Oh my gosh. Look at this. It just keeps going. Wow, I'm going to lose my mind over this. Okay, I'm not going to worry about knocking any of this stuff off. I don't care. It's never going to have a function again. So we're just going to get all that off. Look at this. This is like stage 4 metastatic cancer here. This is like the worst it gets. It's going under the driver. Look at that. It's going under the driver. Looks like we got it all though. Get out of here. We don't need any of this. Barbaric, but is what it is. There's a via here. No, all good. Alright, I think we got it all finally. See, if we would have attempted to turn it on like that, we would have had it would have burned more. So we don't want that. That looks good. Well, it doesn't look good, but it looks, you know, you guys know what I mean. None of this looks good. Looks like a PCB that's been brutally carved. But alright, I'm going to remove all these caps and resistors in the way. Just that. And now I think we're safe. We could check and see if there's a short to ground. I don't really like to do that until it's fully cleared because it's just a waste of time. But now we'll know if we need to do more. So this is going in tone mode, okay, just so you guys can hear. That's ground, and PP bus is in the kiloohm, so I think we got it, guys. I'm really reluctant to turn this board on until it's ultrasonically clean, because all that copper under the M1 So we're going to ultrasonically clean it, and then we're going to see if we have 20 volts, this is essentially there's a path to data. So let's ultrasonic this, and my microscope just fell, and let's see what happens. So we'll be right back. Alright everyone, so our board has been ultrasonicked. There's our whole, look at the size of that compared to the overall board. Like I can almost put my finger through the board, but ultrasonicked it, got all that copper debris out of here. Now we are going to plug it in and see what we get. Basically in M1s, if we have 20 volts, we basically are booted and have a path to data. So that'll be a very good thing if we have 20 volts. I have our HDMI plugged in. I am going to plug this in here. So here we go. 20 volts, that's very good. That was a chime. I don't know if the mic picked it up, but that was a chime. Let's wait for it on HDMI. We're not going to get anything on the internal screen, so I'm watching that little colored stripe to see if it gets anything. Usually it'll be after it boots into the Apple logo with these newer machines. So we're newer meaning 2021, 14 and 16 inches. So after it boots fully, we'll get an image. There it is. There's something. Well, it's a black screen. There we go. That is a it's basically a login screen. It doesn't show the actual login because that's on the internal display, which even unplugged, it won't show properly. But that is an image signal that is booted into macOS, and being booted into macOS, that means we have a path to data. So this was a fantastic save. This was by far the worst internal short I've ever seen and fixed. But it works, and now we can get this person's data back and save the day. So thank you for watching. This was an incredible case, and I'm really happy to have solved this one. See you in the next video.